databases are definitely needed for any business application, right? Either you are developing a, business centric application or a gaming application or maybe social networking application. For all these business application, we definitely need a database. So database, 20 years back, 25 years back, we used to have very limited options or varieties. But these days, we could see there is a lot of different engine within relational database, and we also have a lot of not only SQL database, and we also have data warehousing and so on. So we slightly need to understand why this evolution and why there is a lot of different databases that are available in the market, especially these days when application developers are developing their business application. They are developing it as microservices. So when I say microservices, for example, let's say let's go and I'll show you something here. So let's say shopping or e-commerce application and microservices. Okay, so if I go and look at here, so there are different um, stuff that are there. Let's say like within, if you log into Flipkart or Amazon, you will see that there is a lot of product listing, and you will also see some promotions and the pricing list, and then you will have the checkout cart, and then you will have the list of orders that you have placed in the past, and then the invoices and so on. So there are different type of sub elements, or within that same e-commerce application we have multiple different microservices or sub business features. So what they are doing currently, they are not using the same database for all the microservices. Instead, for example, if you want to store the orders or if you want to store the invoices, if you are storing it in a relational database and if you are trying to query and fetch that document, it is going to take a lot of time, right? Instead, what they are trying to do is like they are trying to put the invoices into a document DB, and then similarly the promotions into a much faster NoSQL DB, and then maybe the product listing they are putting it into the relational database. So earlier, if it is a monolithic application, we just had an option to go for only one database, which might be like mostly relational database services. But now, since the application development has changed, there is a lot of different microservices that we create for each and every application. See, if you log into eBay, you might think that it is one single application, but in reality it is not one single application. It comprises of many different microservices within that e-commerce application. There is a lot of different interfaces, and each of these sub services or microservices can have its own database. So for example, for the individual user account, you can store it in account database. For the inventory service, you can store it in inventory DB. So for the shipping related details, you can also put it in a separate database. So since the microservices evolution, so databases has got multiple different shapes, and we can use any variety of database as per the best fit for that particular microservices requirement. See, before we get into that, generally there are two type of business application. So we call it as OLTP and OLAP. So OLTP stands for online transaction processing application. So anything that is transactional in nature. So let's say you are doing any short transactions. Maybe you are sending money from one person account to another account, or if you are purchasing some product, it is a transaction. And if you are sending some courier, that is a transaction. So anything that is very short in nature, or any small transaction, like mostly the day-to-day operations. So today you will book train ticket, tomorrow someone else will book that same sleeper berth, or they will book the same sleeper ticket on the bus, and so on, right? So it is a day-to-day kind of activities. It is a day-to-day transaction, I would say. So when I say day-to-day operations, I'm referring to the administration related task, right? Taking regular backup, or taking a snapshot, or taking a image from a particular server, creating a template, creating a new virtual machine or creating a new database. So these are all day-to-day operation, and these are all transactional in nature. So they are requesting for it and you are creating it. And similarly, like when it comes to application, there are certain tasks that you do on a regular basis, and bus ticket booking, money transfer from one account to another account. So these are all kind of repetitive in nature. So it continues to happen. Either you book it or someone book it. So the things are repetitive, and it will continue to happen, right? And this is like what is happening currently. Okay, so you are doing the transaction now. It is a very short transaction, I would say, and it's a simple transaction. It's like logging into a portal, booking a train ticket, booking a bus ticket, or booking a movie ticket. So these are all short single transaction. Okay, so whereas the OLAP, online analytical processing application, it's slightly different. See, when you go and book a ticket, so you might have multiple tables. So let's say you are logging into Book My Show. So Book My Show will say will see a list of cities. So cities is a kind of table that you will see, and within that, if you choose a particular state, and it will start showing you which kind of theaters are there in that particular location, and within that theaters, like what are the different movies that are there. So these are all interlinked tables. Okay, so when you are opening up the city's listing, it opens up the cinemas listing in that particular city, and then it shows up the list of movies that are there, and then you get the layout and the different options within that. So these are all interlinked tables, or I would say like there are multiple tables that form up the databases, or any relational database. So here, when you are going and booking a ticket, you are just going and modifying a particular seat or a few set of records in that particular layout or in that particular movie, right? So that's how online transaction processing will happen. So it will go and update or modify, or a very few set of records, not many, right? Maybe it might be one record, or it might be a few set of records. Whereas from the name, it indicates it is analytics processing. Analytics is what has happened already, right? It's not current, it is already historical, right? It has already completed. And let me give you some example here. So if you are trying to understand how your business is performing, let's say you are trying to understand the trend of the product sales, or the pattern of how the users are purchasing, or how the consumers are purchasing your product. And these are all, we are talking about analytics, right? So what kind of uh, purchase model that the customers are doing, so why they are not purchasing this product, and why people are looking for a specific product in abundance. So it will help us to understand what is the current trend, what is the current pattern, and based on that, this analytical processing will help us to take a business decision. So business decision, or we think about it, and then we could take a proper action. So here we are going and uh, looking at millions of records. See, let's say I want to understand what is the Sony television sales across the world. Let's say I want to a particular product. Okay, so XY is that product from Sony. I want to understand how the sales is happening in the global market. So maybe like let's say Europe market, and then let's say India market, and then we have US market, and so on. So if I want to do that analytics or analysis, right? So I cannot do it just like that. So I have to get a lot of data. So maybe in the European market, they might be storing the data in relational database. In India, maybe they're in a small shop, they might be storing it in an Access database, or they might be putting it in an Excel file. Or in US, they might have something on an NoSQL database. So there might be varieties of data format, data coming it for our analysis. So this is where nowadays there is a lot of need for data analysts, data scientists, and data um, related roles that are popping up, where they have to go and analyze the data, and then find out what exactly is happening in the market, and where exactly we have to focus in the business, and then improve the business. See, if a product is not selling, then it's of no use of coming up with a newer version of that product. Either we should redesign it, or whether we should come up with a product which is kind of uh, in good demand in the market, and we should try to increase the production of that particular product which is in high demand, and then stop or reduce the production of the product which are not getting sold. See, the data analyst is not going to help, I mean, not just going to look at just this data. See, even I've seen data scientists, data analysts working on multiple different aspects also. So let's say you have a shopping mall, right? Let's say Sony shopping mall, and then they will try to analyze what is happening and why people are choosing a particular product and why they are not choosing a particular product. They have to do some analysis, right? So what is the option for them? So they will gather all the surveillance camera data, and then they will try to understand how the people are looking at the products and how they are purchasing, and then why they are not purchasing a particular product. So maybe I'll make it in another simple way, like when we are entering a shopping mall. So maybe let's say we are getting into the men's floor, okay? And in the men's floor, if every dress like the shirts and pants are, if it is kept in the rack, people might not be able to touch and feel, or maybe they might not be able to understand the fabric, or they will have very less access to those shelf items. Whereas if the products are in hanging pattern, or if the dresses are easy to touch and feel, and then try to understand how it looks like, and then the purchase might be little higher, right? So that's how the marketing strategy or the sales strategy has changed over the period. And if you go to many shopping malls, you will see nowadays you will have access directly to that product instead of someone showing you after you choose the color and all those things, right? So this is how the data analyst go and analyze the surveillance camera data, and then they tell them, see, I could see that the hanging materials are getting sold very quickly, more than compared to the list of items that are kept in the shelf, and so on. So these business analysts or data analysts, data scientists, they go and help grow the business. Okay, this is mainly to understand how the business is happening and where exactly the business can focus, and they can provide you inputs to this will not happen on a regular basis. See, this is repetitive, right? Book train ticket booking, or movie ticket booking, or money transfer. So these are all happening on a regular basis. The transaction are repetitive in nature, but then the analytics, I mean, we cannot invest money in a business analysis every now and then. So this will happen on a very ad hoc basis. Maybe like when there is a dull in the business, they might involve someone to help them with analyzing and then understand how they can improvise the market. So they will go and look at the trend pattern, not just the data alone. Even they will go and look at different formats of insights, source of information. So they will also go and read the reviews, feedback, and then they will get to understand where exactly we are not excelling, why exactly the business is going down. Maybe the people are looking at these products at a very higher rate, or maybe this is costly for a particular region. So they will try and change the production mechanism for that, aligned to that region. Maybe the affordability is different range in a particular region, so that way they will start manufacturing and only selling products to a particular region which is at an affordable rate. So there will be a lot of review, lot of analysis, lot of insight, discussions, collaboration, communication will happen in order to get to a particular thing. So at times, like, it might be quarterly review, or it might be annual review for a particular business, and they will give you information. See, you cannot just go and do on a regular basis, on a daily basis. It will be a too much of overhead. See, for example, if we are manufacturing car, like, newer models come every half yearly, or every quarterly, or every year only, right? So you cannot just go and do analysis on a daily basis or a weekly basis. Instead, they have to do it based on the frequency of product releases and manufacturing. So if it is a different fabric industry, or a healthcare industry, or a different industry, maybe the cycle might be different. The analysis might be done in a very frequent basis compared to some industry. So automobile manufacturing might not need the same level of analytics happening. So it will happen in a ad hoc basis. See, since why I said historical, the data is already there with us. Some the product is already sold, or product is not getting sold. We already have the event. We already have the log with us. So it's all about going and auditing the existing data, and in order to find out what is happening. In order to understand what is the trend, we need to go through a lot of complex querying. We have to understand how what is the mechanism to go and fetch that data, because we will get the data in various data type, various data format. You might be getting mixed input, so you have to normalize the data first, and then after normalizing, you need to find out which columns to filter out from global region, and then we have to derive it. So it is pretty much complex compared to the OLTP. OLTP is a straightforward business application where we are just doing transaction, and we are completing it, right? So here, if I go to my slide, I can just show you. Yeah. So this is what I'm talking about. Did I miss something? Yeah. So concurrency, right? So there is a lot of challenges around concurrency where a lot of people will try at the parallel time. So you know how the train ticket, the Tatkal time works, right? A lot of people will try in parallel, and then there will be a lot of concurrency issue, and you'll have to plan for that kind of loads. And in the online analytical processing, it's mostly like individual queries. The query will run for a longer duration, so the query will be very short here. Whereas here in online analytical processing, the query is long running, right? Because it has to fetch the data. The query might run for 1 day, 2 day, or even a week. It might take to come and show you the result, because it is going and touching huge volume of multi-dimensional data. Unlike your online transaction processing, in online transaction processing, there is a huge volume of transaction. In a minute, 1,000 people will book train ticket in a particular train, or maybe in the same portal, maybe lakhs of people are booking train tickets for different travel locations or different destinations and so on. So there will be a huge volume of transaction that will happen. So these are all good examples, right? Top 5 examples. So sending money, enrolling for a course, or doing some shopping on the e-commerce site, taking money from ATM, booking a hotel, booking a train ticket. So these are all good examples, right? And then if you talk about online analytical processing, so to understand how the business has performed in the last 1 year or 1 month, and what is the top selling product and what is the product which is not selling properly, top 5 selling products and top 5 not selling products, right? So you can go and identify those, and then you can reduce the manufacturing, or you can try to go with the newest trend. So these are all something which helps you to get actionable insight for the future planning. So that's how the business can go and decide. They can discuss. See, once the business owner might not have the time to go and look into each and every data, so that's where they are hiring the data analyst, data scientist, and they are helping them with getting them a visualization of what is happening globally, and then that insight will help them to go and fix it. See, online transaction processing is mostly application or application specific or application oriented. So let's say I'm creating a business application for an application. So I will go and use a OLTP database, like a SQL database, right? That's what we are trying to relate. And then when you are doing a this is a subject oriented thing. So we are going and analyzing why my business is failing in Europe region, why my business is not succeeding in India region, what might be the reason. So this is how we will go and get the data from our data warehouses, and then this is subject oriented. We are trying to analyze and then find out how we could improve on that particular thing. So here in an online transaction processing, there will be some people, they will go and book the ticket, they will go and cancel the ticket, there might be some read, there might be some write. So both will happen here in on online transaction processing. Whereas in online analytical processing, we are going and reading the data, we are going and understanding what is happening, what has happened, and so on. So it is mostly read operation. The engine has to be more inclined towards read performance kind of thing. So this is where these kind of people gets involved: data analyst, data scientist, business owner. These are the kind of roles that will be involved or more closely working on OLTP concept. In OLAP, we will have database administrators, application owners, business owners, and so on. So these are the people that will be involved on the OLTP category. So database admins and so on. So this is a very high level comparison about online transaction processing and online analytical processing. So yeah, so queries or updates are very frequent. And so who bought X is a transactional question, right? This particular product in a particular showroom, who bought it? It's a straightforward question. But then how many people brought a product in this particular day or in a particular month or in that entire year, right? That is a question where you have to go and look into the reporting analytics, and then it will go and look into huge volume of data, and it will come back. So that is the main difference between OLAP and OLTP. So OLTP systems are more related to your ATM, the web application, streaming, and so on. So yeah, so this is also one more way of looking at it. So if you look at here, operational databases are online transaction processing applications will use the operational database, whereas the business data warehouses will be used for the OLAP. When you want to make a decision, you will go and fetch the data from data warehouses. When you want to do the regular day-to-day operations, then the business process will happen in OLTP. So the daily activities is happening on around OLTP. But if you want to go and look at the historical information and come out with a business insight or business to make a business decision, you will have to use the OLAP concept. So now coming to the other category. See, we have not got into the Amazon RDS topic yet, but I'm just giving you a kind of background why there is a lot of new evolution and why people are going into these stuffs. Okay, so now comes the SQL versus no SQL. So 20-25 years back, we might not have heard about not only SQL, we might have heard about only the SQL category, SQL category, and the not only SQL category is very popular these days. So many querying language has come, and all the not only SQL categories, right? So this is structured query language, whereas this one is not only SQL, not only structured querying language. So there are a lot of different, uh, not only SQL querying languages. There are a lot of stuffs available in NoSQL category. Some people call it as NoSQL. That's fine, but it really means it is not only SQL, and it is much more than the SQL database is what they are trying to convey. Okay, so this is more structured in nature. As the name indicates, the data is already in a very format, in a very structural format. See, let's say we have a city table, we have a cinemas table, we have a movie table. So these are all structured into rows and columns to start with. I would say like these are all mostly tables, and which has got the rows, columns, and the data is very much structurally aligned. So what we do with relational databases, we go and define the schema first, right? We say like how many rows are needed, how many columns are needed, what kind of data types it has to accept, whether it has to accept variable or what kind of data type it can accept, whether it can only accept integers in a particular number row or number column. So we will go and define what kind of rows, what kind of columns. We define the schema before even going and storing the data. This is how generally SQL has been used, and the schema is pretty much static, right? I would say it's a static schema. You can change it later, but you need a lot of downtime to change it and so on. And SQL databases or SQL category, they have a lot of dependency with licensing. So for example, if you want to go and use relational databases from Microsoft SQL or let's say Oracle, so these are all commercial databases, right? These are not open source, so we have to go and invest a lot of money, and all these are licenses are tied to the physical processor, right? Physical components. So we have to go and purchase licenses based on the number of processors we are using in a physical hardware, and physically it has a license tied up. So if you want to have more servers, then you have to invest on more amount of licenses, and that in fact it is a huge investment. So what generally we do is we generally do vertical scaling in the RDS database server, the SQL database server. The reason is, since it has license tied to the processors, and if you're adding more servers, automatically based on the number of processor, you have to procure a lot of licenses, and we cannot invest money. So what generally, like, they will go and add more CPU and then more memory when there is an issue, and within the same single hardware, they will try to utilize to the maximum so that they don't have to invest in additional licenses from the vendor, commercial vendors like Oracle or Microsoft. It will be a lot of challenge. So here, these SQL queries are more suitable for OLTP applications. So if you are trying to connect to OLTP applications and trying to access the data, then the backend can be SQL. SQL databases are more relevant or more suitable for the OLTP applications, where they can store the data and quickly fetch it. Okay, so whereas here in not only SQL, it is more suitable for OLAP categories, or I would say it is less likely used for OLTP apps, but it could be used. It's not that it cannot be used. So the main different between these things are, this is mainly unstructured, or I would say it is semi-structured. You don't have to really follow a predefined schema. There is no predefined schema here. You can go and update the data on the fly. You can. It is very dynamic in nature. There is no static schema here. The data is very dynamic. It is very unstructured. See, for example, you might have heard about JSON files or document DB and graph DB. These are all very different formats. See, when you go into the Workday, or when you go into the Facebook or any portal, you will see a lot of relationship information coming up. See, if you are going and storing those information in SQL databases or relational databases, the graph formation will take a lot of time. But instead, if you are storing the data in a graph database, let's say, like, you will automatically see who is the friends of friend, or which person is reporting to which manager, and which manager is reporting to these people. So those kind of hierarchical information or interrelationship data can be stored and fetched quickly from a graph database. So different business service or different microservice might need its own variety of information storing and fetching. So that's the reason you could see a lot of wide variety of not only SQL databases coming up, and that has got a lot of additional flexibility, like integrated caching, and maybe there is a I mean, in SQL, there is one more challenge, that it will have it requires more downtime. If in case you want to modify the schema, or if you want to upgrade or update, there is a lot of downtime here. Whereas here, the updates are automatic, and outage is very less time. Okay, less outage time required. So whereas SQL is very rigid in the schema, and we have to take a lot of downtime and get that sorted out. So when it comes to SQL, the biggest advantage is the commercial database, right? So it has got great support. So you will get you can raise ticket with the vendor, Microsoft or Oracle, and you can get better support here. Whereas the not only SQL, there is a lot of community dependency. So you have to wait for the community to do that same proof of concept, and then they have to wait for the model to come up, and then it takes little time. But if whatever it is already readily available, yeah, we can go and leverage it, use it, and then it will be much easier. So when it comes to SQL, as I told you, there is a lot of multiple tables that are interlinked. So for example, here they will have, when you go and click on this cities, it will go and list down the list of cinemas, and when you go and click on the cinemas link, it will go and open up the list of movies. Behind the scene, it is a table, okay, and that table is kind of getting visually represented in a much appealing format, right? So what they do to interlink these tables, so then generally have something like primary key and foreign key mentioned in that particular table. So that will denote where exactly it has to go, and if I click on this link, which one I have to go and open. So those kind of key based joining will be there in your SQL. So each table will be interlinked. So table interlinking will be there. Tables will be interlinked. and generally people call it as joins. Okay, so joins using primary key and foreign key and so on. If you have learned Microsoft SQL or Oracle database during your college days, you might have heard about primary key, foreign key, and so on. So here there is no joins. Okay, so but then it also provides you a lot of powerful interfaces are there. Okay, where you can go and easily get the information. If you're running some complex query, it is easy to go and fetch it. So here, mm, okay, what information? Okay, so here vertical scaling I told, right? So here it is suitable for horizontal scaling. There is not much licensing complication. So you can go and add more servers if in case you need more users processing, or if you need more processing power, you can go and add more instances and more servers, and horizontal scaling is much suitable for your uh, not only SQL category. Okay, coming to the slide, I thought I had something. Yeah, so these are some of the example for SQL, and then these are all some example for not only SQL, for gaming application, social networking application, IoT application. So we have got wide variety of options here: key value database, document database, columnar database, and so on. So these are all utilized for different use cases. And here also you can see that. For your web application, mobile application, and enterprise application, you might have relational databases which are stored into multiple tables, and you might be using joins. So SQL is very common for your enterprise business application, but in the recent past, the gaming applications, the social networking application, the IoT applications have change the requirement, right? So completely nowadays we are highly relying upon some kind of document databases. See, for example, let's say you are opening up a uh, mm, let's say travel portal. Okay, in travel portal, what kind of data you will have? You will generally have what are the locations, what are the sightseeing spaces, and then there will be a lot of document information. What is the procedure for applying visa, or what are the places to visit? So if you are storing that information in a document format and then retrieving it, it will be much easier for those requirement. So based on the requirement, the way of storing the data and retrieving will be much faster. So we will then generally do a POC, right? We will try to use the relational database. We'll try to find out how much time it is taking, and similarly we will try to find how much time it is taking when you're storing the data in document DB. So the latency testing, the throughput testing will be handled, and you will get the output here. So yeah, so this is what I was explaining, and there are some different options here within relational databases. You have Amazon RDS, we have got Amazon native database, Aurora database, and we also have support for commercial and the community editions. When it comes to non-relational database, Amazon provides you key value database in the name of DynamoDB, and you might have heard about MongoDB, right? That is the equivalent. And Amazon Elastic Cache for in-memory caching, Neptune for graph database, and document DB in the name of Redis caching and Memcache. So there are many different options that are available to choose from when you go for AWS, right? And this is another way of looking at the comparison, right? Database versus data warehouse. So in short, these are all completely interlinked items. Database versus data warehouse. So I'm saying why it is interlinked. So OLTP versus OLAP, and then database versus data warehouse, SQL versus no SQL. So all these are similar in nature. So all these are tied to each other. So OLTP, SQL relational databases are much suitable, and similarly for OLAP, data warehouses are much suitable. So these are interlinked items. So if you want to compare, you can just use it this way. So let me put it here so that I can explain about the database and the data warehouse. So database, like so that is where you store the data. Data warehouse is where you process the data. Okay, database is a backend for your business application. So this is mainly for your specific. Okay. So this is application oriented, in other words. Okay, for each and every business application, you will go and create a database. You can also share the database across multiple applications, shared across apps. So here it is mainly subject oriented. So it might not be one single database. You might go and fetch the data from multiple different database. So here we are storing the information in much detailed format. So you can go and get every single information: who made the transaction, when he booked it, what compartment he chose, what kind of source, destination. So all the detailed information will be here. So whereas here for data warehousing, it cannot accommodate every single data, because it is going to get the global information. It is going to consolidate all the data from different data types, data formats, and you will get a very consolidated or summarized data in data warehousing. So it cannot store every single data. So the minute information will be stored in the database. So it will have a structured input or information, like with a structured schema, I would say, make it simple. So here this OL data warehouse, it is designed for fetching the information or querying the information. It is designed for analysis, in other words, in simple words. Okay, so the data warehouses are designed for querying the data, reading the data. It is mainly for reading the information, whereas the databases is fine tuned for both reads and writes. Because some people will go and cancel the ticket, some people will go and book the ticket, someone will go and overwrite the same ticket the same time, right? So there will be a lot of overwrites, reads, writes that will happen in real time. So this is completely historical in nature. So we are talking about something already happened, and we are going and checking it. So here mostly the data will be flowing in, right? Whereas here the data will be fetched. Data will be, okay, instead of ins, I will say just in. Okay, so it is related to OLTP, and this is related to OLAP. I will see if I am missing any important information. Let me just put it here. I think I already covered almost the same content. Yeah, detailed relational view will be available. Here summarized multidimensional will be okay. So this is mainly for business insight, to understand the patterns, trends, and so on. Whereas this is concurrent transaction. So people are logging in, booking the ticket, sending money, transferring something, or purchasing something. These are all very short transactions which are repetitive in nature and happening currently. These are short, simple, single transaction, I would say. This database. Data warehouses are suitable for fetching a large amount of data. Millions of records will be read, and then it will get the summary of what has happened, and we can make a decision. So this is what you need to be aware of before you get into the Amazon RDS.